Good morning, students. Once again, I welcome you to my video lectures on GATE. Once again, to continue with problems from 2022 EE stream paper. In the circuit shown, switch is closed at t equals 0. So, this is the switch which is closed at t equal to 0. The magnitude of the steady state voltage, in volts across the 6 ohm resistor is dash. 2 mark question. So this is 6 ohm resistor, and what is the steady state voltage? Now if you recall your memory on network analysis, you have studied in network analysis a chapter called initial conditions. So along with initial conditions, final conditions are also there. But here in this problem, we have to find the final condition. So the condition at steady state is also called as final condition. That means at t equal to infinity. Initial condition means condition prevailing at t equal to 0. Now this is a problem from initial condition and final condition chapter. Now you should know one basic, that is charging of capacitor. Charging of capacitor. For example, take a capacitor and take a source and a switch and don't bother about the value of this capacitor. Now as soon as the switch is closed, immediately this capacitor is charged to 5 volts. That means a deposition of plus charges on this plate, deposition of negative charges on this plate. So it is immediately charged to 5 volts. Suppose if you take resistor here, then the charging process is delayed. So larger the resistance, larger will be the time constant, and the charging takes place for some time. Ultimately it is charged to 5 volts. So this is the basic. Once the capacitor is charged to 5 volts, then under final conditions, how it behaves? This 5 volt capacitor will behave in this manner. It behaves as a 5 volt source connected in series with an open circuit. Because current cannot pass through, once capacitor is charged to 5 volts, then there cannot be current in the circuit because this 5 volts opposes this 5 volt source. Therefore, a capacitor, a charged capacitor in the final condition is represented as a 5 volt battery in series with an open circuit, then resistance. Switch is closed. And this is what is called as final condition. So representation of capacitor under final conditions. That means current flowing in the circuit stops. So you should know this point in this problem. In this problem you apply this knowledge, your knowledge on charging of capacitor. Now the switch is closed. Once the switch is closed, then capacitor is charged to some voltage. We don't know to what voltage it is charged. You can find it at the end. I will tell you what is the voltage ultimately across 1 microfarad. Now as the switch is closed, then current flows through 6 ohms, current flows through 3 ohms, then capacitor is charged to certain voltage, then current flowing stops here. Then once current flows stops here, this path can be treated as open circuit. I have already told you that this behaves as an open circuit. This branch behaves as an open circuit here because capacitor is fully charged to some voltage, not 10 volts. It is not charged to 10 volts. It is less than 10 volts. I can find out at the end. Now once open circuit is created here, you can find out what is current through 6 ohms, what is current through 3 ohms, and you can find out voltage drop across 6 ohms. This is under final condition. So under final condition, the current. Now I will find current through 6 ohms. So 6 and 3 in parallel. 6 and 3 in parallel. So equivalent resistance becomes 6 into 3 divided by 6 plus 3. That is 2 ohms. Equivalent resistance becomes 2 ohms. That 2 ohms is in series with 2 ohms. So 2 plus 2 becomes 4. 10 volts divided by 4. That means 2.5 amperes. So current drawn from this source is 2.5 amperes. So this 2.5 amperes cannot flow here. It has to flow through these two resistors. So what is current through 6 ohms? Current through 6 ohms is 3 opposite term resistance into current divided by the sum of the resistance, that is 6 plus 3. That is 3 into 2.5 divided by 9. That is 2.5 by 3. Sorry, 3, 6, 9, 3, 2.5 by 3. So 2.53 is the ampere current flowing here. Sorry, current direction I have to reverse. Because this is positive, so current has to flow like this. Now voltage drop across 6 is 2.5 by 3 into 6. 2.5 divided by 3 into 6. That is 2 that is 5 volts. So answer is the voltage across 6 ohm resistor is 5 volts. If you are willing to know to what voltage capacitor is charged, you can find to what voltage it is charged. It is calculated in this manner, and in this circuit, please slightly change the polarity. Polarity is this is plus, this is minus, because current is flowing like this. Now the capacitor is in this path. So this capacitor is also charged to this voltage across 6 ohms or this voltage across 3 ohms. Just now we have found out the value as 5 volts. Therefore, capacitor is also charged to 5 volts. Thank you.